Hello, we're going to get started as always. We are so close to break. I was trying to think of how many days. You have this full week, and then you have Monday and Tuesday next week. Reminder, Monday and Tuesday. Monday is full live classes. Tuesday you will have assigned work. Then you are on Christmas break. So with that, we're going to get started. Today's topic is a lot to write down. So I understand that today's notes are going to be a lot to write. That is why I'm going to make sure that they are full points in the grade book. So please, in whatever way needed, first of all, use the flipped grid. Please turn in your notes at the end and make sure that I can see them. You will have exactly what this page should look like. You'll have the pre-review at the top, which is a quick kind of run through of multi-step equation, and then we'll have 3 new problems. We're only doing 3. Now, I say only because they are a lot in each problem, and I understand that. That's why we're only doing 3 of them. Please make sure that you get everything down on the paper, and then we'll go through that. Without further ado, let's start with review. Review, we've got a multi-step equation. So we've got variables on the left, the right. We have also constants on the left and the right. Our goal is to get the variable by itself. So if you said the variable by itself, that's what we are looking for. So we're trying to get r by itself, and we'll be doing this all day today. So my go-to is to always move the constants to the right, and we'll go back and forth with each of these. But in order to get the 7 from the left to the right of the equation, I'm going to subtract on both sides. So we're going to minus 7. Bring down the 6r. We now have 13 minus 7 equals 6, and bring down our 7r. All of our constants are now on the right side of the equation. So in order to move the variable 7r to the other side, I'm going to need to, if you said subtract 7r, that is perfect. It's the inverse of plus 7r. So we're going to subtract 7r from both sides. That cancels out my 7r on the right side. On the left side, I do need to be careful because 6 minus 7, we do have a negative 1r equals 6. Now, if I just left my equation like this, that's not going to be right because our r, or our variable, cannot be negative. So I'm going to divide by negative 1. That cancels out my negatives on the left because a negative divided by a negative is a positive, and then we should get r equals negative 6. Now, I crushed through this, so if you want to go back and rewatch, that's fine. But this is a lot of what we are going to do today. We've been doing systems of equations by graphing 2 lines. So you put it on a graph and you visually see if they connect. If they don't connect, it's no solution. If they connect at every point, that's same solution, or like that's it. But this time we're going to look at one solutions when we just do equations. So you don't have the option to graph it. You are just going to need to find it like actually algebraically, which is doing this. So this is number 1. Remember, you have 3. Going back to like that first page, how I set it out. This is number 1. There is a lot of steps in it. So please, A, get all the steps down. And B, and B, you have make sure you write kind of smaller because you've got a lot of steps. So first thing, get your systems equation down. Now that you got that down, we've got 2 equations. Y equals negative 3x plus 4. Y equals 4x plus 10. Now you could graph this, but we don't have graph paper. So what I'm going to look at is I'm going to take that first equation. We're going to set up a equation with variables on both sides. Now, our goal is to find out where they intersect, or where do they meet. So our goal is to find out what is the x value that's shared by both of these, and what's the y value that's shared by both of these. So I'm going to take this equation. That's our first equation. I'm going to look at the second equation to help build that like big equation. So I'm going to look at the second equation over at original. Now I see in the y equals negative 3x plus 4, I have this y. The same thing that's in both of these equations is this y equals. So what I'm going to do is I'm going to replace in this equation right here, the negative 3x plus 4, I'm going to replace the y with what the second equation is, because I know y equals this in this equation. I know y equals 4x minus 10 in both equations. So if we know the y is the same, we're going to replace the y with what's in the other equation. So let me be clear. I took this first equation. I'm replacing the y with this 4x plus minus 10. Now, I could have done it the other way. I could have said 4x minus 10 equals y and replaced it with this one. Either way, the y is being replaced with the other equation. Now it looks like our setup of our multi-step equation with variables on both sides. So let's run through this. We're going to go ahead and add 3x to both sides. We're going to move the variables to the left in this one. When we add them, you've got 4x plus 3x, 7x. Drop down your minus 10 and drop down the plus 4. All our variables are now to the left. Our goal now is to get the constants on the right, which we need to move that negative 10. So the inverse of minus 10 on both sides would be, if you said plus 10, that is perfect. We're going to add 10 to both sides, and we're going to get 7x equals 14. Now, the only way to get x by itself, right now 7 and x are being multiplied together. So the inverse of multiplication is division. And I don't have this on here, so my apologies. We are going to divide by 2, and we know x equals 2. Okay, if I were graphing these two equations and they met right here, this point, I would know I'd have to go over to the x's 2, but I need to know the height because we're looking for that point of intersection, which is an ordered pair. So usually when it's a one solution graph, you can give me the ordered pair. This is only one part of the ordered pair. So let's go back to that first equation. Y equals negative 3x plus 4. Okay, I know that that's one of the lines on the graph. I want to find out what's the y value when x is 2. So what I'm going to do is take that equation and I'm going to insert 2 for the x. That way we get rid of one of the variables. So if I insert 2 for the x, we have y equals negative 3 times 2 plus 4. Now I just need to solve it. Negative 3 times 2, negative 6. Negative 6 plus 4, careful on this one, is negative 2. I now have an x and a y value. So if I were to ask you, based on these two equations that are right here, this system, what is the solution without a graph? And I'm looking for an ordered pair. This is how we go about doing it. Believe me, we'll do it 2 more times. So you have an ordered pair of 2, negative 2. So again, it'd be a lot easier if it went on a graph, but sometimes you don't have the graph. So in order to do this, we've got to replace our y's. And we replace them so that they kind of chunk together. Okay, let's do a second one, number 2. And again, if you missed or if I was going too fast, pause, rewind, rewatch, but we are going to go through 2 more equations like this. So I see a system of equation. I could graph it, but I don't have graphing paper. So what I'm going to do is I'm going to look at this system. Both of them have y equals. So what I can do is replace the y in the first equation with what it equals in the second equation. So let's look at that first equation. I'm going to replace the y in that equation with what it is in that original second equation. So I'm going to take the 6x minus 8, because I know that equals y, and just replace it in this y. So we're going to move it over to that other one. So we have 6x minus 8 equals negative 4x plus 2. Again, we replaced the y in the first equation with what it equals in the second. Now we got a multi-step equation. So we're going to add 4x to both sides. I'm moving the variables to the left. And we're going to do 6x plus 4x, 10x, drop everything else down. Now that our variables are all over on the left, we do need to figure out how to get the constants to the right. So what's the inverse of minus 8 on both sides? If you said add 8, we're on point. We get 10x equals 10. Now without showing you, that is multiplication. 10 and x multiply together. The inverse of multiplication is division. So you got x divided by 10x divided by 10, 10 divided by 10, x equals 1. Okay, that is one part of our solution to this system. Again, we're looking for that coordinate point. That is the point where these two lines cross. I know that x equals 1. I need to solve what will y equal. So I'm going to take that equation first. We got y equals negative 4x plus 2. We're going to replace the x with what we just solved as the answer, which is 1. So I'm going to replace the x with 1. Okay, now we're down to one variable. Y equals negative 4 times 1. Negative 4 times 1, negative 4. And then we go negative 4 plus 2. We get negative 2. I now have an x and a y. So I can put those together and I find my ordered pair, which is 1, negative 2. So we've done a few things. We were presented the original systems of equations. We were going to solve for the x. Once we solve for the x, theoretically, actually, I could put in either equation because x equals 1. 6 times 1, 6. 6 minus 8, -2. I could put in either equation. I picked the top one just because. Last one, number 3. Okay, so we're going to start with the equation y equals x plus 5 and y equals -2x minus 4. Again, we have our original equation, the first one. We need to get rid of the y and replace it with the other equation. So I'm going to take that blue y, take my second equation, and I'm going to transfer the -2x minus 4. So we got this right here. I'm going to go ahead and move my x's to the right this time because I don't like the -2x. So we're going to go ahead and add 2x to both sides. We do have -4 equals 3x plus 5. All my variables are on the right, so my goal is to get the constants to the left. So we're going to go ahead and do the opposite of plus 5, minus 5. And then we have -9 equals 3x. Okay, 3 and x are being multiplied. We do need to get x by itself. So we're going to divide both sides by 3. -9 divided by 3, we get -3 equals x. That is one part of our solution. I know what x equals. I need to figure out what y equals. And again, I could use either equation. I'm going to use the top one first of all because it's easier. It's x plus 5. So we take x plus 5. There's my x. I'm going to replace it with what I just solved for x. So we now have, and be careful because this next is negative. So we're going to have to go ahead and make it a double negative because you have -x, but x equals -3. So we have two negatives. A negative times a negative, you do get a positive. So we have 3x plus 5, or 3 plus 5, I'm sorry, which y equals 8. Okay, I've got my x and my y. So we've got -3 and 8, which our answer for our solution is -3 and 8. This is everything that you've got. So you got 1, 2, and 3. We will review this for tomorrow's live session and probably on Thursday too because this is a lot. Please make sure that you turn in your notes on Flipgrid, and I will see you. I'll see you tomorrow. Have a great day.